everyone, my name is Steven, and I'm going to talk about the competition about juvenile Atlantic salmon and steelhead, relevance to invasion potential in British Columbia. And this is my second talk. I hope it won't be so wordy and you guys won't fall asleep. The first species today is salmon sailor, also known as the Atlantic salmon. Due to its fast growing speed and good marketing price, it was widely farmed in many places in the world. And it also occupied nearly 80% of the agricultural products in the British Columbia. And the second species is Aquatic micis, also known as the rainbow trout and steelhead. And it is the native species in the river of British Columbia. And it also displays significant niche overlap, which means the steelhead lives in the same area with the Atlantic salmon. So they may confront and compete for the resources and the territory in the wild. And this is the distribution of the Atlantic salmon in British Columbia. The Atlantic salmon were hatched in the fresh water and then transferred to the marine net pens to grow to their marketing size. So the yellow circle means the licensed Atlantic salmon farm, and the red cross means the sightseeing of the Atlantic salmon. You can see that in many rivers, the Atlantic salmon had invaded into many rivers, so they may confront the steelhead, which is the native species here. So in this research, we want to know that the juvenile Atlantic salmon and the steelhead, which species have more advantage to survive in the wild British Columbia River. And this is how we sample the fish. The parental fish means the parent fish. The parental steelhead is collected from the river in the British Columbia. And the parental Atlantic salmon are taken from the local agricultural facilities. And both fish are kept until they hatch. And we collect the F1 progenies, which means their baby. We collected the F1 progenies and kept them in the rearing tanks for 20 days until they adapt the environment for the experiment. And how the experiment's progress is under the natural photoperiod means the sunlight. And this is the experimental channel. On the right hand side is the inflow pipe, which allows the water and the feed comes in the channel. And on the left hand side is the outlet pipe, which drains the water and the waste out of the channel. And there are two screens to keep the fish inside the channel and prevent them from escaping. And there are 6 bricks in the channel, which provide the space for the fish to rest and hide. Here is the full experiment. The experiment is divided into 2 groups, the high feeding rate group and the low feeding rate group. The high feeding rate group means the feed is 2 times more than the low feeding rate group. And one group has 6 channels, and the numbers in the channels means the amount of the fish. And the AS means the Atlantic salmon, and the steelhead is ST. So if the channel is 4 plus 4, means the channel is high density. There are 8 fish in the channel. And if the channel has only 4 fish, which means the channel is low density. And one channel fish is also divided into two fish, 2 kinds of fish. The resident fish and the challenger fish. The challenger fish means the fish were introduced into the channel 3 days after the residence. And also, the whole progress is with 3 replicates. And here are the 4 variables we record. The foraging means how many times the fish eats the feed. The organism means the more intense action. For example, the fish attacking or chasing each other. The cruising means the fish change its swimming direction. And we also record the change of weight and length at the end. The experiment is lasted for 13 days and one observation is lasted for 5 minutes. And we put the V-clip on the fish pectoral fins to identify them. The first table is the overall weight change and the length change. You can see that on average, the 2 species of the fish both lose their weight and both of the species increase their length, which means the fish had grown up, but they got thinner. So you may ask why the fish grow up but they get thinner. Because the experimental channel is too sparse and shallow. Sparse means there is not enough structure in the channel. So the lack of sufficient structure to provide the visual isolation may increase their energy expenditure and their activity level. And the other reason is the limited food. If the fish cannot get enough energy, they may lose their weight. The next table is the overall frequency of foraging and cruising. The number here, 1, 2, 3, means the 3 replicates of the experiment. And the number here means how many times the action was counted in the 5 minutes. You can see that in the both variables, the steelhead is higher than the Atlantic salmon. And the next one is the frequency of organism. The organism is divided into the intra-Pacific organism and inter-Pacific organism. So you also can see that in these 2 organisms, the steelhead is also higher than the Atlantic salmon, especially the steelhead. Here, they are 7 times more than the Atlantic salmon. So the 3 variables above, the steelhead have performed better in the 3 variables. So can we say that the steelhead is the more dominant species than the Atlantic salmon? No, not at all. Because the greater aggression isn't equal to the superior competitive ability. You can imagine that a villain who likes to fight and argue with other people doesn't mean that they have a better life. The result above can show it, below can show it. Here is the weight change among the resident and the challenger fish. The challenger fish means the 3 were introduced into the channel 3 days after the resident. You can see that if the Atlantic salmon acts as a resident and the steelhead acts as a challenger, the residents, the Atlantic salmon, increase their weight and the challenger lose their weight. So it can prove that being as a resident, the Atlantic salmon is performed better than the steelhead. The next table is the different weight change in the different density. In the low density situation, means one channel has only 4 fish. In the low density situation, the Atlantic salmon lose less weight and increase more weight than the steelhead. So we also can say that the Atlantic salmon perform better than the steelhead in the low density situation. And here is the steel status. The rivers in the British Columbia used to have many Atlantic salmon, used to have many steelheads. But due to the global warming, overfishing, and human activity, the amount of the steelhead had decreased intensely from the past few decades. So there are many empty space for the Atlantic salmon to grow. So, the population of the Atlantic salmon increased rapidly in the past few years. And here are some other survival advantage for the Atlantic salmon. The earlier spawning and hatching season. The Atlantic salmon's spawning and hatching season is about 15 days to 1 month earlier than the steelhead. It also has the size and age advantage and higher growth weight, which means the size of the Atlantic salmon is usually bigger than the steelhead in the wild. And having the bigger body size is the advantage for the Atlantic salmon. So the Atlantic may say, I win, you lose, loser. And here is my conclusion. The Atlantic salmon are capable of colonizing the vacant or underutilized habitats and of successfully defending that habitat against subsequent challenges from steelhead. So, the steelhead is in danger from the Atlantic salmon growth. Thanks for your attention.
Okay.